Ever wondered how AI generates images? It's not magic, it's layers of understanding, and today we've got all three. Meet the beginner. He'll walk you through the full journey from how AI breaks down an image into noise to how it slowly builds it back again. No equations, just the essential process, what happens and why it matters. Then there's the intermediate. He'll take you deeper into how the image becomes noise, the math behind the forward process, and how AI learns to reverse it step by step. Here, things start to get real with noise schedules, sampling, and structured denoising. And finally, the expert. He'll take you to the core of it all. The architecture that powers the generation, the UNet, the loss function, the training loop. Not just how images are created, but how the model is trained to create them. Let's hear what the beginner has to say and start at the beginning. Hey guys, I assume that you know when AI generates images, it does not just draw it out of thin air. It starts from noise, total randomness, just like TV static. But before it learns how to create, it must learn how to destroy. This is known as the forward process. Take this image for example. It starts off clean, full of color, detail and meaning. But watch what happens as we begin to add noise. Bit by bit, the image gets messier until it looks like pure static. This part is called the forward process, and it's completely controlled. At every step, we know exactly how much noise is being added. Now comes the hard part, reversing it. The model looks at the noisy image and tries to guess all the noise that's been added. Then, step by step, it removes that noise until the final image appears. And that's the journey from image to noise and back again. I've just given you a rough overview of what happens behind the scenes. Now let's hear it from somebody who knows how it actually works. Well, I believe now you have a basic understanding of what's happening. Let's dive deep into the technical aspects of forward diffusion and reverse diffusion process. The forward diffusion process is where we gradually add noise to x0, this is the initial image, step by step creating x1, x2 all the way to xt, which is almost pure noise. This noise isn't just dumped in, it's added using a schedule, usually a linear schedule or cosine schedule, so each step is controlled. Once we've added all that noise, we do the opposite. Reverse diffusion process is where the actual generation happens. At each step, the model looks at a noisy image and tries to predict all the noise that was added from the beginning until now. Not just the last step, the entire cumulative noise. Then, it subtracts a bit of that predicted noise, giving us a cleaner version. A common misconception is that people think the model just removes a small amount of noise at each step, but that's not accurate. The model doesn't decide how much noise to remove. Instead, given a noisy image, the time step it came from, it predicts how much total noise has been added up to that point. The prediction is then subtracted step by step, slowly recovering the image. To summarize, the forward process adds noise using a known schedule. The reverse process uses a trained model to estimate the noise and then remove it step by step. This is the backbone of how a diffusion model works. But how do we train a diffusion model? Let's bring in someone who knows how to train one. So far, you've learned what diffusion models are. None of these processes happen by accident. There is a network behind it that is trained to estimate the noise. It's called a UNet, a neural network architecture designed to understand both global structure and local detail. Images go in on one side, get compressed and processed in the middle, and are reconstructed on the other side. Skip connections help the model retain high resolution features while learning abstract ones. At each step in the reverse process, the model takes in a noisy image and a timestamp, and then it predicts how much noise was added up until then. But the real magic is in how we train it. Let's quickly look at the steps of how to train a diffusion model. Step 1. Start with a clean image. Step 2. Add noise to that image using a random time step from the forward diffusion schedule. Step 3. Give the noisy image and the time step to the model. Step 4. The model predicts the noise it thinks was added. Step 5. Calculate the difference between the predicted noise and the actual noise and minimize it using a loss function. Repeat this across millions of images and hundreds of noise levels, and the model becomes a master at reversing noise. Now that's how we teach a model to generate images. Not by showing it how to draw, but by training it to reverse noise one step at a time. That's how AI generates images.